Okay, here we go. This is very much a classic question, however, with a slight twist to it. As you'll see, we've got identical resistors arranged in different networks. We've got the same potential difference, and we want to know which one has the greatest electrical power. So, as ever, please have a look, and then when you're ready to go, click play to see the answer. Now, this is as I say, I think this is a twist on a sort of typical question from IB. IB loves these questions of different networks. We're combining series, parallel, and you're kind of getting a bit more and more complicated as you go through them. Okay, now when we're talking about the greatest electrical power, remember we've got the same potential difference. We're looking at resistance, we're looking at power. We want to link those three quantities together, and we're going to use the idea of P equals V squared over R. Now I've noticed just going through these videos, it's really helpful for me because I noticed that P equals V squared over R is a really commonly used equation when we're looking at electrical circuits in multiple choice questions. They really love that equation. No idea why. It's just a good test of your understanding. Key idea here being we're looking for power going up as resistance goes down. So if I'm asking you for the greatest electrical power, really I'm asking you which one has the lowest resistance. Now, hopefully you know the answer straight away by looking at this. However, I think it's worth our while just having a look first. So if we've got our top one here, it's a series combination. We've got RA is equal to R plus R plus R, and then we've got 3R there. Okay, so that is going to be our highest resistance because when we add things in series, add resistors in series, I should say, we are going to increase the resistance. The next one's slightly more complicated. Okay, we've got a resistance of R, and then we've got these two here. These have an effective or total resistance of R over 2 because they're splitting into those two sections. So we have 3R over 2. Notice that's less, so our current candidate is B. Apologies for the typo here, that should be RB. I hope I've not done that. Yes, and the next one I've got it right. The next one, a little bit harder, we're going to do 1 over RC because we're adding in parallel. We've got 1 over 2R on the top and 1 over R on the bottom. Okay, which gives me 3 over 2R, I should say. Okay, remembering to flip that to give 2R over 3. Yeah, but remember when we do the 1 over the reciprocal resistance, we also actually need to remember to flip it as well. Okay, last one, we've got 1 over RD. I've had a nightmare here with my nomenclature, but never mind. 1 over R plus 1 over R plus 1 over R, 3 over R, and therefore RD is R over 3. So again, we want highest power, lowest resistance. That means D is going to give us our highest power because of that low resistance. Okay, now like I say, I sort of said it right at the beginning, there's a chance here that you could have just spotted that straight away because you know that those resistances are that when we arrange in this parallel circuit, then that is the lowest resistance combination. It's always a good test of your ability to do these questions, just to give it a go, give it a try and see if you can do that calculation.